What are the most promising technologies that might enable net zero skyscrapers in the future? Do you think net zero is attainable on a wider scale for tall buildings?
Yeah, it's an interesting question. When we look at an individual buildings, and certainly a tall building, at least the technology that we have in hand right now, we don't really think it is possible to achieve net zero. We've done some studies at RWDI that show maybe 5 stories would be the limit given existing technology. However, there's a lot of things that could be done on a tall building that really reduce demand. I think careful attention to design of the curtain wall, for example, energy efficiency there. We see a lot of good examples here in China, Shanghai Tower, for example, with double skin facade. And I guess another area is it's important to, I guess, control energy movement around the building. So attention to stack effect. So stack effect is something that's manifested by movement of air through a building due to buoyancy, due to temperature gradients, but there are good design techniques that one can use to manage that. You asked the question about whether a single building, and as I say, for a single building would be very hard to achieve, if not impossible, for a tall building, at least in our current understanding. But perhaps on a broader scale, so perhaps a master plan scale, or then that might be something that's achievable.
What are the major limits then for individual buildings? The sheer amount of space, or the power of renewable energy technology, or the sheer amount of use? What are the main things limiting the possibility of net zero skyscrapers?
Well, there's a big energy demand. There's energy demand in moving people around. There's energy demand in just plug load, thermal load, and it's a practical thing. On the energy generation side, we haven't seen the technologies yet that really enable sort of that balancing off with the demand, with the generation. For wind generation, maybe to be specific to that, we have seen some good efforts on that front, but I think the ability to generate energy from wind due to turbines on the building has been limited to date. Perhaps looking to smaller scale turbines, if that might be a technology that develops in time, or photovoltaics that might be smaller scale, easier to implement rather over the facade of a building. Those might be some examples that push us down the road a little bit further.
Mm-hmm. So demand and generation side need to be leaps and bounds.
That's right. That's
okay.
right.
What do tall building designers need to do to improve disaster resilience or climate resilience?
Yes, climate resilience, disaster resilience. Actually, tall buildings as a class of structure are quite resilient. They have a higher level of design effort. They're designed to more specific data, whether it be earthquake, whether it be wind. Those are very specific studies conducted. And so the engineers, both structural engineers and mechanical engineers, and I guess the people transport aspect of it with elevators and egress, that's all advanced quite a bit in the last. Certainly the latter point there has advanced quite a bit in the last decade. So I think they are overall quite resilient structures in comparison to normal design. Where they could be better, I think that there's always incremental improvements that one can make as far as going deeper with the structural design, or looking at perhaps different egress scenarios. But I think on the whole, they're quite resilient.
Maybe put another way, do you think they're resilient enough, given where we're headed with climate change and current projections?
I think as much as we understand climate change today, yes. I think when we look at wind loading in particular, and how that might change due to climate change, we see that the increase in demand is fairly moderate over time. So there might be a 50-year wind, for example, that might be something we designed to today. You know, that might be something that's closer to a 100-year wind down the road. Or sorry, other way around. 100-year wind is closer to a 50-year. So it's a very slight increase in demand over time, at least if we follow the models as we understand them today.
So you design for a 50-year wind the same way someone might do a 50-year or 100-year flood?
It's the same basic thinking that the overall reliability would design to say a 50-year or 100-year event, and then we apply various safety factors just to make sure that that the overall reliability is achieved.
That's interesting. You sort of already answered this, but I think we can maybe zero in on your wind engineer's perspective about it. Is there any inherent upper limit to building height? And especially from, you know, a wind engineering perspective, what are the key challenges as you scale up to 1,000 meters and beyond?
Yeah, with the Kingdom Tower and buildings, you know, 1,000 meters and above, we really start to push our level of understanding of I guess, winds at those levels. So our best understanding of wind naturally is at ground. We have some good understanding of wind as it relates to, say, 600 meters. We did some studies on the Kingdom Tower and earlier on Burj Khalifa to examine what the wind speeds are at higher levels. Those results actually look pretty favorable, but it is pushing into an area where we don't have the same level of data. So that has to be looked at with a degree of caution, of course. So that would be one, I guess, limit, although it's not something that we can't overcome in a particular design.
Any others?
Well, the effective wind goes with the square of the height, or actually a little bit more than the square of the height. And as you get more tall and slender, then there's different effects of wind that come in. So shape becomes much more important. Subtle changes in the architecture can have quite drastic changes, or quite good changes and negative changes, depending on the subtleties of the shape and how they influence the overall loading.
That might lead into our next question. You mentioned the square of the height, so higher up buildings should have greater potential to harvest wind energy, right? Although I think I remember it's something like the cube of the diameter of a wind turbine, right?
That's right. Yeah. So the energy potential on a wind turbine goes with velocity cubed. So yes, the velocity does increase as you go up, but it doesn't increase with the same effect as the load, if I could put it that way. So the wind speeds do reach a point where they do tend to they don't increase as significantly in height, and in some cases they don't increase at all. They tend to flatten out. But you do have a larger region of the building towards the top where you could look at energy harvesting due to wind turbines or through wind turbines.
How successful or how useful would that be? I guess the question I want to ask is what are really the opportunities for harvesting wind energy in tall buildings? Is it substantial? Is it an untapped potential? Or is it, we've seen projects where it's basically window dressing, right? Where it's a marketing tool. Is it underexplored? Or what are the main challenges there?
Yeah, I wouldn't say it's window dressing. I'd say it's more than that. I think every effort that has been put in has brought broader public attention to it, which I think is a valid and a good reason in and of itself. I haven't looked at any specific case, but likely I guess the drawback would be that when you do put wind turbines on, it does increase the drag. So it's like putting an additional sail on a sailboat. You want to make sure that additional sail actually gives you some benefit. So putting that extra drag element introduces some further demands on the structure that supports it. So each case has to be looked at carefully that way. But I think there is potential if perhaps smaller scale type of turbines. I don't know what that implies as far as energy generation or the scale of the actual generators themselves, where that technology sits right now, but that might be some potential.
So you see this as a field of growth, maybe when renewable energy, wind harvesting on tall buildings?
I see it, yeah, I see it as a growth. I don't see a huge potential in it compared to other technologies looking at wind energy overall.
Mm-hmm.
But I think from putting some spotlight on it, I think it is a worthwhile endeavor to pursue.
We have just a couple of minutes left, but
Sure.
that made me wonder how you think renewable energy, wind energy specifically, could factor into tall building development, if not necessarily as much directly on the building. Do you think it's a driving force or potentially a field of growth for tall building development in general, maybe integrating it with other kinds of renewable energy, other systems, utilizing the stack effect you mentioned earlier, things like that?
Well, that's an interesting question, the way you pose it. I think that there are ways to shape a building to take advantage of the natural wind flows around it, or the natural effects that are there anyway. There are ways to enhance those. So, looking to solar gain, perhaps some other type of techniques to implement or enhance some of the stack effect, and setting up the building cores so that you can actually generate a shaft and perhaps have some energy generation at the top. I've seen concept buildings like that before. All areas of good promise. I think the potential still as a real meaningful energy generator for a particular building is limited at present, but as I say, I think it's still worthy of pursuit. And I think if we look at tall buildings and the case for tall buildings, I think it only adds to sort of enhance that public image of a particular building to have some of those technologies on it.